Shalom to you and welcome. In this video, you will be learning how to calculate the geometric mean and simplify radicals. Radicals are in simplest form when no perfect square other than 1 is under the radical sign, and no fraction is under the radical sign, and no fraction has a radical in its denominator. Okay, we'll look at all these in an example. All right, let us review perfect squares. Perfect squares are 1, 4, 9. These are numbers that when they multiply themselves twice, you get them. So if you multiply 1 twice, you get 1. Multiply 2 twice, you get 4. Multiply 3 twice, you get 9, and so forth. So these are perfect squares. And if you take the square roots of each of the perfect squares, you get their root. Okay, so take square root of 1, you get 1. Take square root of 4, you get 2. Take square root of 9, you get 3, and so forth. So one of the rules of simplifying radicals says that we can't have any perfect square under the radical. The radical sign is this sign. Okay, the number under it is the radicand. So whenever we have any of these numbers, perfect squares under the radical sign, then it is not yet simplified. So we have to find the perfect square to simplify it. So 16, square root of 16 times square root of 4. We look at square root of 16 is 4 because 4 times 4 is 16. So this is going to be simplified to 4. And then once you write 4, you don't put square root sign anymore. And then times, and then 4 is the perfect square also. Perfect square root of 4 is 2. So square root of 4 is 2. Again, we don't put square root sign anymore. Then 4 times 2 is 16. So we have simplified square root of 16 times 4 times 2 is 8. Right, is 8. So we have simplified square root of 16 times square root of 4 is 8. Next example, square root of 75. Well, we look at here, 75 is not a perfect square because it's not here. Square root of 75 would fall between square root of 64 and square root of 81, somewhere in between here, because 75 is between 64 and 81. So it's not a perfect square. Then we think, is there any perfect square that can divide into it with no decimal? Remember. So if you can try dividing it with each of these numbers and see if you get one. But also another way to do it would be taking the prime factorization of 75. So that gives it to us right away. So if we try to divide 75 by all the prime factors. So again, prime numbers are numbers that no other number can divide them except themselves and 1. So 2 would be prime number, 3 would be prime number, 5, 7, 9, 10, 11, 12, 13, 17, and so forth. Okay. So we try to divide this. Look now, 75. 2 cannot go into 75. Can 3 go? Well, we'll try. If the sum can divide by 3, 7 plus 5, then it will. So 75 divided by 3 is 25. So 3 go into that is 25. And look, hey, 25 is a perfect square. So 25 is a perfect square. So the square root of 75 is the same thing as the square root of 25 times 3. Okay, so those two numbers. So if you multiply them, we get back 75. So now that we find this, we can split them. Square root of 25 times square root of 3. Okay, and square root of 25 is 5. And square root of 3 is not a perfect square, so we leave it like that. But it is in simplest form now. Next problem. 2 times square root of 48. All right, 48 is not a perfect square. Then let's try to find the prime factorization. So if we take 48, start dividing it with prime numbers. So 2 go into 4, 2 go into 8, 4, 2 can go again, 2 divide 2, 1, 2 divide 4, 2. 2 can go again, 2 go into 12, 6, 2 can go again, 2 go into 6, 3. All right, 2 is gone, and then 3 is also a prime number. So here we have 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, because there are 2 pairs. See, there are 2 here and there are 2 here. You can do 2 times 2, that will be 4. But otherwise, you can do 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. So we know that this is 2 times square root of 48. Square root of 48 is going to be the same thing as 16 times 3. They are still all under square root. So again, because these 2 times 2 times 2 times 2 times 3 is 16 times 3. So here we keep 2, we split square root of 16 and square root of 3. And then now we know square root of 16 is a perfect square, so which is 4 times 4 is 16. So we change that to 4, and then we keep the square root of 3. So now these 2 and 4 are ordinary numbers. So 2 times 4 is 8. Multiply them, 2 times 4 is 8, and then we keep the square root of 3. It is in simplest form now. Alright, fractions cannot be under the radical sign. Here, fraction is under the radical sign, which means it needs to be simplified more. So what we do, we just multiply the numerator and the denominator by the denominator. So here, multiply the numerator by 5, multiply the denominator by 5, and these are still, it's 5 over 5. So these are still under the radical sign, all of them, okay? So now we multiply 2 times 5 is 10, still put the radical sign, over 5 times 5 is 25. Okay, so now we can separate them, separate the numerator from the denominator. So we do square root of 10 over square root of 25. Okay, so 25 now is a perfect square because 5 times 5 is 25. So, and that's why we actually do that, multiply by the denominator, so we can get identical squares. So now we put this 5. So that removes the square root under the denominator and remove fraction under the radical. It is now in simplest form. Okay. Now let's talk about geometric mean. But before we even talk about geometric mean, let's review arithmetic mean, which we are very used to. When you find arithmetic mean, it's just finding average of numbers. If you're finding arithmetic mean of 3 numbers, there are 3 numbers here, R, S, T. What we do, let's say arithmetic mean AM is going to be R plus S plus T. We add them and divide by how many they are. There are 3. We just divide them by 3. So since they are variables, we can't really do anything now. So that will be the answer. So geometric mean, on the other hand, instead of adding them, we multiply them. So let's say geometric mean, GM, is going to be R times S times T. And instead of dividing them, we take the root of how many there are. There are 3 of them, so we're going to take the cube root of them. So that's the geometric mean. So what if you have 2 numbers? We have 2 numbers. The arithmetic mean is going to be the same thing. Just add those 2 numbers and divide them by how many there are. There are 2. Just divide them by 2. For geometric, you're going to multiply them, our sign says, and take their square root because there's only 2 of them. Now take the square root. Okay, so if you notice, when you multiply 2 numbers, like when we cross multiply in a proportion, so if we put it in a proportional form, if x is, let x be the geometric mean of 2 numbers, any 2 numbers at all, then we can express them in proportional form like that. The geometric mean x would be up and down here. The two numbers r and s is going to be cross, because we are going to cross multiply them. Okay, and by the formula, so if we cross multiply them, then the x here, excuse me, so the x is going to be x times x is going to be r times s. X times x is x squared, which is r times x. So if you take the square root of both sides, then x becomes r times x squared. And that's the geometric mean. X is the geometric mean. You take the square root of those two numbers. Okay? So you can use them to solve problems. Alright, find the geometric mean of these two numbers. What do we do? 3 and 27. Their geometric mean is going to be, take the square root of their product. We take the square root of their product. None of them is a perfect square. So if they are not perfect square, we just go ahead and multiply them. So, okay, 3 times 27 is 81. Okay, so that's good enough. So that gave us a perfect square. 81 is a perfect square because 9 times 9 is 81. So, sorry, this is 9. Okay, so that's the geometric mean of that. Next, how about 22 and 55? Okay, again, the geometric mean is going to be the square root of their product. Okay, 22 is not a perfect square, 55 is not a perfect square. Okay, multiply them. 22 times 55, you get 1, 2, 1, 0. Okay, and then we check to see if it is a perfect square. We kind of put them into square root. Find the square root. No, it is not a perfect square, so we need to find a perfect square that goes into that. So we can take the prime factorization. All right, 2 can go into 12. You get 6 and 0 and 5. You can use calculator to go fast. Okay, so 1210 divided by 2, we get 605. 2 cannot divide anymore. Can 3 divide 6? No. Then we try 5. Okay, so this divided by 5 is 121. Oh, good enough. 121 is a perfect square because 11 times 11 is 121. So, okay, so we can take these two, multiply them. So this is going to be 121 times 2 times 5. Okay, all those three numbers there will make up that. Okay, so 121 is a perfect square, and then 2 times 5 is 10. And they are both still under the radical sign. So this is 11. 121 will become 11 square root of 10. That is the geometric mean. Now,